ఇంటర్మీడియట్ విద్యారంగంలో అగ్రగామి మన NSR ఇంపల్స్ ఎడ్యుకేషన్ ఇన్స్టిట్యూషన్. ఐఐటి జేఈఈ అయినా నీట్ అయినా తిరుగులేని విద్యా సంస్థ NSR ఇంపల్స్.
Hello students, now we are going to discuss about the chapter of transport in plants. Theoretical concept we have discussed including the phloem transport. Phloem transport includes the translocation of food materials. We even discussed sorts and spring are variable. Now in this transport in plants, now so far we have discussed all the concepts including diffusion, facilitated diffusion, osmosis, translocation, transpiration including phloem transport. Now let us discuss about some numericals on this. Let us take for example for cell A. For cell A, for cells, let us take for cells means let us take a continuation of some cells like A, B, C, D. Right? What we will do for cells A, B, C, D. The solute potential. What is the symbol for solute potential? Solute potential symbol is nothing but psi s, or this also can be written as psi pi. Solute potential or is also called osmotic potential. Solute potential itself is also called as what? Osmotic potential. Either it can be written as psi s or psi phi. So the solute potential and pressure potential. Pressure potential means psi p we can take. Pressure potential value is psi p. Potential values are, so it is given like this. So for again I am writing R for cell A. For cell A it is given that 0.5 and 1.2, right, and for cell B it is given that something like minus 2.3 and something like 1.7, and for cell C it is given that minus 1.2 comma 0.5, and for cell D is given that minus 3.2 comma 2.1, right. Then the numerical question is for 4 cells, we take into consideration of 4 cells. For 4 cells A, B, C, D, the solute potential means psi s they will give value, sometimes psi phi they will give, and pressure potential values are for cell A these two, cell B these are the 2 values, for cell C these 2 values, for cell D they are the 2 values. Of course all are given in terms of megapascals. The unit for this all is given megapascals. Then the question is given, find out movement of water or movement of solution. So when you take this all, how to calculate, how to find out? Now generally we take into consideration of water potential values. Now let us take the cell, all that cells, let us take the solution here. How we have to calculate? Let us take all 4 cells. This is A, B, C and D. So here we can write what are the values are given. Solute potential value is given, pressure potential value is given. When both are given, when solute potential, pressure potential values are given, what we need to calculate? We need to calculate what is called water potential values, right. Now let us take this. A solute potential value is given as 0.5 and pressure potential is given as 1.2 megapascals. Similarly for B minus 2.3 and here it is given as 1.7. For cell C it is given that minus 1.2, 0.5. For cell D this is minus 3.2, 2.1. Now, accordingly what we have to calculate? Definitely we need to calculate water potential value. So, here water potential value is always equal to solute potential plus pressure potential. Now, for A, if you look at A value, if you take, what is that we write? 0.5 plus 1.2, how much you will get? Approximately you will get 1.7 megapascals. So, for cell A, when you take, the water potential value can be calculated taking into consideration of solute potential plus pressure potential. So, for cell A, it is given that 0.5 plus 1.2, it is written as 1.7 megapascals. Now, for this I will write the 1.7 megapascals. This is given 1.7 megapascals, which we calculated, right. Now, coming to cell B. For cell B, now we take again the same formula. Now, we write minus 2.3 plus 1.7. Now, this if you take a 0.6 you will get it, that is minus 0.6 megapascals. So, here the value is a water potential value for cell B, it will be given as minus 0.6 megapascals. Similarly, for cell C, if you look at, same formula we apply. What are the values given? Minus 1.2 plus 0.5. Then what is the value? You will get it as 5 plus 2, 7, 0.7, right. That is minus 0.7 megapascals. So, we can write this value as minus 0.7 megapascals. Similarly, for cells D here, let us take D here. Now, what is the value? Minus 3.2 plus 2.1. Then how much you will get it here? 9. So, 1.1 minus 1.1. So, we write the value as here, in this case minus 1.1 megapascals. So, when we take this all values, the water potential values, when you take for A, B, C, D. Now, what is the thing we studied? Minus values if you take, the greater, the smaller is the number, itself is the biggest number. So, if you take the minus values, minus 0.6, minus 0.7, minus 1.1 and 1.7 megapascals. Now, if you take the solution A, let us take the solution A, it has 1.7 megapascals. What is the meaning of this? Plus value we always take on upper hand, 0 above values. Minus values we take 0 below values. So, the movement is happens from where to where? Now, if you take the water movement, we write water movement always occur from, water movement always occurs from where to where? Higher water potential to lower water potential, higher water potential to lower water potential. Very important, right. It always occurs from higher water potential to lower water potential. That means which has a higher water potential? Let us take cell A. Then which is next to a higher water potential value? We take minus 0.6. Then next highest water potential minus 0.7. Next is minus 1.1. That means here the movement of water occurs from A to B, B to C, C to D. Suppose in the given options, the option is not there where the movement is happening, because minus 0.6 is having higher water potential when compared with minus 0.7, that has greater when compared with minus 1.1. That means lower is the minus value, greater is its value. So, minus bigger number will have the lower value. Sometimes in the given options A to B, B to C, C to D, connection is not given, then sometimes they may give you options such as, so from here A to B and A to C, A to D. All the above may be given, correct only. Or sometimes the option will be given B to C, B to D. But still the options we have to take into consideration, right? Then what will be given? C to D. If these options are given out of 4 options, then all the options will be correct. Then which are the options which are not correct? D to A, D to B, D to C are not correct. C to A, C to B is not correct, right? B to A is also not correct. Except apart from this, if any of these options are given, then you will get the option as all the above. Why? Because the movement may happen. If you take the cells like this, from here to here movement happens, from here to here movement happens, from here to here movement happens. Similarly, higher to lower, B to C and B to D. Similarly, we also find C to D. That is why according to the water potential values, remember the water movement occurs from higher water potential to lower water potential, right. Now, accordingly we have to take into consideration of this. Now, let us see the next one. Let us study now some numericals today. The solute potential and pressure potential. The solute potential value, what we will write? Psi S, and pressure potential psi P of some cells. Let us take the cells as of something like PQRS, are given in the following table. Maybe it is given that are given in the following table. Find out or arrange the cells, arrange the water potential values. I am writing complete question. Water potential, that is psi W, values in ascending order, That means the one which has lowest water potential to the one which has highest water potential. At the question they may be asked either in terms of ascending order, sometimes they may ask you the descending order. Right. Then what we can do at this time, maybe the given table is like this, P, Q, R, S. So, the table is given like this, right. Now, in this the solute potential values, pressure potential values are given. Let us take for P is minus 0.6, minus 0.1, let us take, and then coming to this something like 1.2, let us take it as minus 0.5, and take this as something like 2.6 minus 1.3, and let us take this one something around 2.0, let us take 1.0. The table is given like this. Then they may ask you arrange the water potential values in ascending order, or they may ask you descending order. Then ascending order means lowest water potential to highest water potential, not the highest water potential to lowest, no. When in the question if they mention about ascending order, then you have to arrange them in lower water potential to higher water potential. Do not arrange them as higher to lower, very very important. Most of the students they confuse here only. Even though they say ascending order, but they will arrange as for higher water potential to lower. They always, because after solving few numerical questions, they will get a habit of arranging them in higher water potential to lower water potential. But in the question, when it is mentioned as ascending order, guys, don't arrange them as higher to lower. Make sure that you have to arrange them from lower water potential to higher water potential, because we have to go in ascending order. Now, so here let us take water potential values. In this case here, now here let us take the first one. Now, what is same thing we have to apply, that is water potential is equal to solute potential plus pressure potential, right. Now, for cell A, minus 0.6 plus 0.1, that minus it will become, then it become minus 0.7. Then coming to this will become 0.7, and here you will get it as 1.3, and in this case you will get minus 1, because we have to employ the same formula, solute potential plus pressure potential. Now, when you take this case here, what is that question? The question they mentioned about ascending order to ascending order. Let us take about ascending order. Now, which are the cells which have lowest water potential? Lowest water potential is the one which has greater minus value, that itself will be having the lowest water. Minus 1 is nothing but the smaller value, but it has greatest water potential. Let us take the condition. For example, if you take minus 0.7 plus 0.7, you got the two cells as minus 0.7 plus 0.7. Sometimes in the question, let us take the same question is given. Now, I am giving you question number 3. Let us take the question number 3 also same. Find out which cells are in equilibrium. Find out which cells are in equilibrium. Suppose same question is given, let us take it as third question. Now, in the third question they ask about find out which cells are in equilibrium. Then when you take the values of water potential, look at carefully here, cell P is also have minus 0.7, cell Q is having plus 0.7, and these two cells are in equilibrium. If the solution goes here, it becomes minus. If the solution comes here, it becomes plus. Right. So, plus and minus, but both are in neutral condition, that is plus and minus values both are in equilibrium. The answer for that question, if this is the question is given, then we can write what is the answer for this? P and Q are in equilibrium. It is said to be P and Q are in equilibrium. Right. Now, the one which has the lowest one, let us take it as minus 1. Then coming to this one, I am writing it, minus 1 is nothing but S, then nothing but minus 0.7, right, lowest value having minus smaller value, smaller is the value, greater is the what you call water potential. Before that what we find, smaller is the value, greater is the 1. Ascending order we are going. So, S then followed by P and then followed by 0.7, that is Q, and then followed by R. Right. Then descending order means make it the same, R, Q, P and S. Suppose the same question is given, let us go with question number 4. Same question is given, they may ask you to find out the water potential difference between Now, you take any of the two cells. For example, if you take the difference between 0.7, 1.3, that is Q and R. Let us take Q and R. Then what is the water potential difference between Q and R? Here it is 0.7, here it is nothing but 1.3. So, the one which has 0.7, if you make it minus from 1.3, 1.3 minus 0.7, approximately you will get it as 0.6. So, the value between these two is nothing but what? 0.6 megapascals, right. So, this is how, using the same thing, you have to go with what is called as water potential values. Now, let us go with other one. Let us take question number 5. The two chambers are given. Let us take one chamber is B, other chamber as A. In chamber B, we find very few solute molecules. In chamber A, we find more solute molecules. Right. Now, two chambers, in the question is given that the two chambers A and B are with semi-permeable membrane, When two chambers A and B are with semi-permeable membrane, then they may ask you the question, the water movement and the solute molecules movement, the chamber which has higher water potential, the chamber which has lower water potential. The question may be asked in any of the form. But basically what you have to understand is chamber A and B are interconnected with or traversed by semi-permeable membrane, means the conceptual the question is related to osmosis. Now, looking at this diagram, now what you can find here, in this case you find less solute molecules, but more water. When more water is there, definitely you find higher water potential. Less solute is there, more water is there. Obviously, when solute is less, let us take that some sucrose is dissolved in chamber A and some amount of sucrose got dissolved in chamber B, both are interconnected by semi-permeable membrane. Then looking at this diagram, what are the conditions, you have to get it clear. Less solute molecules means obviously they are dissolved in more water, then higher is the water potential. Automatically in chamber A, you can find more solute molecules. There are many solute molecules are there, less water is there, then lower is the water potential. Now, in this case, the movement of water, remember, always occurs from where to where, as we discussed, always occurs from higher water potential to lower water potential. Always occurs from where to where? The movement of water always occurs from higher water potential to lower water potential. So, movement is happening from higher to lower. That means, according to the diagram, if at all the question is about movement of water, what is the solution for this? Then the solution for this is nothing but movement of water happening from chamber B to chamber A, right. So, here what is happening from chamber B to A, what is moving here? Water is moving from chamber B to chamber A. After that what happens? Again when chamber A is fully filled with water, then again water will take reverse osmosis. Generally we get water, at home we find water purifiers, right. What is the condition we see over there? Reverse osmosis. How people have discovered reverse osmosis? Guys, everything we learn and we get it from the nature. In duck we find in case of ponds and lakes. In duck, some of the scientists they find and they observe what is called reverse osmosis, swans and ducks. they can eliminate dirty water even though they are moving in contaminated water, but they can eliminate contaminated water. From the contaminated water they can absorb pure water. So, looking and observing the nature, especially in ducks, people identified what is called reverse osmosis. So, the same technique we apply till today for the purification of water. We keep water purifiers at home. In water purifiers, what is the principle? Reverse osmosis. So, here when A chamber is fully filled with water, then water will take reverse direction from A to B. At that time, what happens from A to B when it is moving? Along with the water, sucrose molecules will be added to B. Sucrose molecules will be added to B. Then what is happening here? Reverse osmosis. Reverse osmosis happening from where to where? A to B. Until how long it happens? When all sucrose, some of the sucrose molecules will enter into B. It happens, occurs how long? Until it reaches to equilibrium. Until it reaches to equilibrium. So, according to the question you have to answer. Now, maybe in the question, this is one question, let us take that movement of water, and the next question is, maybe find out the one which has higher water potential. Which chamber has, the question will be, which chamber has higher water potential? Which chamber has higher water potential? We already have noted down, for B has higher water potential. I know this, everyone will write correctly, that is chamber B. Right. Suppose the question is, next question is, which chamber has, the same thing I am writing here, but higher solute potential. Higher solute potential. See the difference in the question, this is nothing but psi s. Which chamber has higher solute potential? Then what will be the condition in this case? This is what most of the people will do mistake here. Most of the people will confuse with the question. They think that solute concentration is more here. So, they think that solute potential will be higher for chamber A. So, most of the people they will get confusion here. Most of the people they get confusion here. Most of the people they will write chamber A. If we ask why they have written chamber A, means they think that A chamber has more solute molecules, so it will have more solute potential. So, most of the people will confuse in this question. Most of them writes A, but this is wrong. Why this is wrong here? A chamber if you write, that is a wrong option what you have chosen and loser of marks. Why? Because always remember, very important thing, always remember, solute potential is inversely proportional to solute concentration. Better I will write this side, better I will write all note points here. So, let us take very important note points. So, what you have to remember, solute potential always inversely proportional to solute concentration. What is the meaning of this? That means if solute concentration is more, solute potential is less. A chamber has more solute molecules, that means it is having less solute potential. What is the question asked here? The question about high solute potential, higher solute potential. If the solute concentration is less, then we find higher solute potential. Which chamber has less solute concentration? B chamber has less solute concentration. As B chamber has less solute concentration, B chamber will be having higher solute potential. So, answer for this is nothing but again B will come, not A. Most of the people they confuse here. In doing the questions, most of the people they confuse here. Guys, the chamber which has higher water potential is the same chamber, there you find higher solute potential. That means what you have to understand here, what we have written about water potential, if less is the solute, more is the water potential. More is the solute, less is the water potential, right? Less solute means more water potential, more solute means less water potential. That means water potential also inversely proportional to what? Solute concentration. Water potential also inversely proportional to solute concentration. That means the chamber which has higher water potential is the same chamber which has higher solute potential. That means what is the final conclusion which we have to understand from there? That means water potential is directly proportional to solute potential. Very important. Note points are very important. That means water potential directly proportional to solute potential. So, this is the chamber which has higher solute potential is also B. For example, let us take next question. Which chamber has lower water potential? So, what is the next question? Which chamber has lower water potential? That is already written in the diagram. In the beginning itself we have written. Which chamber has lower water potential? Closing your eyes you can write A. Right. Next question. Which chamber has higher water potential? Which chamber has higher water potential? This is already written here. Nothing but what? B chamber has higher, already we have written, no? Let us make it as which chamber has lower solute potential, because I am giving you in short form, easiest form, higher water potential, higher solute potential, both for both B and B. So, I am making it is very easy to remember in your mind. Higher water potential, higher solute potential, both B and B. So, that is why I am giving you in this sequence. Similarly, lower water potential, write lower solute potential, that is also same. Again A will come. A chamber has lower solute potential and also lower water potential. So, lower water potential, lower solute potential means A chamber. Higher water potential, higher solute potential means B chamber. Very important. Then movement of water occurs from where to where? B to A. Right. Now, so note points are this, very important. Solute potential is inversely proportional to solute concentration. Water potential also inversely proportional to solute concentration. So, that thereby we can say water potential is directly proportional to solute potential. Now, let us take question number 6. Let us take question number 6. Right. Chamber A has I am just erasing that diagram so that you can convenient to understand. Now, let us take chamber A has let us take minus 1000 megapascals, or you write water potential value, directly you take down as water potential values. Water potential value is minus 1000 megapascals and chamber B has, let us continue. So, I am talking about B chamber. Water potential value is minus 2000 megapascals. Chamber A has water potential value is minus 1000 pascals. Chamber B has water potential value is minus 2000 megapascals. Then if this is a given, then what is asked, like the movement of water. The movement of water occurs from, what is the direction of movement of water? That is a question. Or you can write the movement of water occurs from which chamber to which chamber. Then here we say, I always tell you, no, or mostly we have to remember what? Minus is smaller is the number, greater its water potential. minus having bigger is the number, having smaller is the water potential value. Minus 1000 is given, minus 2000 is given, right. Minus 1000 generally people will think that smaller value, but that is itself is a greater value. That means we can write for chamber A. So, one second. For what we write for chamber A. So, we write for chamber A, minus 1000 megapascals itself is considered as a higher water potential. So, it has higher water potential, that is minus 1000 megapascals. Similarly, for chamber B has lower water potential, that is nothing but minus 2000 megapascals. Then the movement of water occurs from where to where? Higher water potential to lower water potential. Then the direction of movement of water, from where to where? Higher water potential to lower water potential. That means movement is happening from A chamber to B chamber. So, in this case we write A to B, not B to A. Okay, in this case we write A to B but not B to A. Right? I hope you all got it, right? Minus with smaller is the value, itself is a greater value. Minus with bigger value itself is a lower value in terms of water potential, definitely. So, the movement of water occurs from minus 1000 is greater value when compared with minus 2000. So, movement of water occurs from A to B, right. Then next question, let us take the next question. Now, let us take that the 4 cells, or let us take the 3 cells, something like M and O, right. 3 cells we are taking, M and O. What are the 3 cells? Let us take, these are the 3 cells. So, here like this, let us take 3 cells. What are, let us call them as M and O. Now, for 3 cells the solute potential and water potential values are given it as. So, let us take water potential value is given it as something like minus or 1.2 you can take. Pressure potential value is given minus 1.2 you take. Pressure potential value is given it as 0.5. Let us take for M, water potential value is given it as minus 0.7 and pressure potential value is given it as 0.3. Similarly, O cell, maybe water potential value is given it as minus 2 here, pressure potential value is given it as 1. Okay. Then here in this case maybe the question is find out movement of, or you can write direction of movement of water. In this case, in the when 3 cells are given, they asked find out direction of movement of water. Direction of movement of water, from where to where the movement is happening. Now, if you look at in this case, what are the values are given? Water potential values are given. But here he may ask you to find out even solute potential values and find out the direction of movement of water. So, what you need to do? First you need to find out solute potential values. So, when you take water potential is equal to solute potential plus pressure potential. Now, you need to calculate solute potential value. So, you take water potential minus pressure potential. Now, you start writing for cell M. For M, if you take for M cell, what is the solute potential value? Water potential is minus 0.7 minus 0.3. Then it becomes, what is the value? It becomes 1.0, minus of 1.0. Coming to N cell, what is the value of solute potential value here? That is minus 1.2 minus 0.5. So, the difference is 0.7. So, you can take minus 0.7. For cell O, if you take, what is the solute potential value? Minus 2.0 minus 1, you will get minus 1 is the value. Now, solute potential values are here. This all are for what? This all we calculated are for solute potential. These all are solute potential values. Now, according to solute potential values also, what do we say? When we say movement of water occurs from where to where? Higher water potential to lower water potential. Similarly, when you talk in terms of solute potential values also happens from where to where? Higher solute potential to lower solute potential. Why this will apply? Because water potential is directly proportional to solute potential. Water potential directly proportional to solute potential. Now look at where to where the movement is happen. Here higher solute potential. The minus 1.0 here, this is also 1.0. So it happens from M to N, right? Because M and O are in equilibrium. Yes or no? Both are in equilibrium. M and O are in equilibrium, and O2 where? O2 again N. That means look at in the diagram here. Sometimes they will give diagrams in the options. So M to O. So the movement is happening from M to O, and also here M to N, sorry. In this case M to N and also O to N. Sometimes in the options they will give the diagrams. So M to N direction, or they will give on O to N directions. In the same question they may ask you which cells are in equilibrium. Next, which cells are in equilibrium? And if this is the case, then you have to remember which are in equilibrium. M and O are in equilibrium. So, when option A is given at us M to N, option B is given as O to N, option C is both A and B, then both A and B will come. Why? Because here the movement not only from higher water potential, lower water potential, movement also happens from higher solute potential to lower solute potential. Where you find higher solute potential? So, this is minus value, minus 1, minus 0.7. Sorry, one second, here 1.0, no? Oh, sorry, 1 second. This is minus 0.7. Minus 0.7 is the lower value. 1 second guys, let me take the values here, 1 second. So, what you have to write? Minus 0.7. Minus 0.7 means N to M will happen, N to O will happen, because minus 0.7 is the highest solute potential, sorry. Right. So, N to M, N to O. So, what is the directional movement you have to write here? In this case, what you have to write? N to M. Where is N to M? Here. This is N to M. Sorry. N to M and N to O. Why? Because compared with minus 1, minus 0.7 is the higher value. I thought this is 7. So, I thought minus 1 is a lower value. But minus 1 compared to that, minus 0.7, 0.7 is the lowest value. Lowest, smaller number means greater value, sorry, that is what I am telling you, do not confuse with this. Having a smaller number, minus 0.7 is the greatest value. So, you have to take this is highest. Most of the students they will confuse here in the exam, right, minus 0.7, minus 0.7 is for N. So, movement happens from where to where? N to M, N to O, and which cells are in equilibrium means again we say M and O are in equilibrium. So, this is always confusing bit for the students. Guys, make sure that smaller is a number is a greatest value, bigger is a number is a smallest value, 0.7 is a higher water solute potential, M is having lower water potential, and these two will be in equilibrium. This always people will have a confusion. Be careful while answering the question. In this movement happens from N to M, this is N to M, N to O, and M and O, but these two are in equilibrium because concentration is same. This is how you have to look for the question, right. So, these are the numericals. Let us have some more numericals on DPD, then we can see DPD values, accordingly you can calculate, and we will see what is the movement from where to where the movement is happening.